Hello and welcome to week 10 in our semester, and here we are in statistics and psychology, and we're entering into some stuff today and this week that has a little bit of complexity to it. So let me kind of explain. We're going to be looking at tests and hypotheses, and we're moving away from descriptive statistics into predictive or test statistics, or essentially moving from simply describing the data that we have collected to the point of being able to make decisions about the relationships between data. We've covered a little bit of that in correlation. Now, correlations are a combination of both descriptive and predictive statistics, because it defines a relationship, which then when we use a regression, we can actually use that data to make predictions about the relationship between two variables. However, as we take a step away from correlation, we start getting into the kinds of tests that give us evidence that there may actually be a cause-effect relationship, or maybe it's part of a model of various variables that contribute to a particular outcome, which is a better description of the reality. And it's kind of the goal of course, of psychology, to describe those relationships. So we first have to take a little bit deep dive into the research methodology of the scientific method, and that is the world of hypotheses. Now, hypotheses are best guessed supposition statements as to what we feel the outcomes of our particular statistical test will be. In a correlation, we can have hypotheses that say, yes, I believe variable A is related to variable B, and is a positive correlation, meaning as one goes up, the other one goes up. As it goes down, versus a negative correlation, one goes up, the other one goes down. Either one of those could be the hypotheses. Think of that in a generic sense. Our hypotheses basically describe what do we think is going to happen. A lot of that, from a scientific perspective, comes from the preponderance of the evidence that we have read so far preparing for our study. This is why just thinking of a study is really not enough to prepare you to actually conduct that study. The literature review is where you get not only what do we already know and what tools do we already know about your subject matter, but what's already been discovered, so that we can make hypotheses in line with what the evidence so far seems to be pointing to. Even when we're looking at new areas of study, we may look at related type constructs that have a certain relationship, and we're going to presume that the ones that we're looking at will have similar relationships to those. So when we look at hypotheses testing in the field of psychology, you have to understand that the default presumption within science is that there is no relationship. Put that really deep into your consciousness. In psychology, we presume at first there's no relationship. We presume there's no relationship until evidence tells us there is. So that's our initial perspective. What we call that is the null hypothesis. So the null hypothesis, null means zero, nothing's going on, nothing to see here, move along. Those kinds of assumptions about the field. So we start with that, and then when we, maybe because of the preponderance of the evidence, or because of initial data that we've collected, or gut feeling, there's a lot of reasons, we may think, I think there is a relationship between these two variables. So we create an alternative hypothesis. And we might say in that hypothesis, yes, there is a relationship between these two variables. So the null hypothesis is where we start. The alternative hypothesis is where we may go if the evidence presents itself. When we gather evidence, and we conduct our tests, we conduct our observations, we come to a conclusion either to reject the null hypothesis and accept the alternative hypothesis, which means there is something going on, so I'm going to reject the null hypothesis and I'm going to say that my data indicates support that there is an alternative explanation for what's going on, and then or we reject the alternative hypothesis and we have to accept that there is no relationship. And statistics, the role of statistics is to give us a definitive line in the sand upon which we are going to make that decision. Science for a long time, absence of statistics, has had hypotheses and provided evidence, but there was really no line in the sand that said this is going to be the self-disciplining line. I'm going to say if the evidence does not meet this high level of criteria, I am going to be forced to reject the alternative hypothesis and accept that there's nothing going on. Now, because we're talking about the statistics end of this thing, not the research methods, that's the next class, we're going to spend some time looking at the normal curve again. We're going to look at probability. We're going to look at those lines in the sand that are pretty standard to hypothesis testing, the 5% line, the 1% line, and I try to explicitly go into that into the course book, but they basically mean that I'm not going to reject the null and say something is going on unless there's only a 5% chance that I'm wrong, or only a 1% chance that I'm wrong. And that's the philosophy behind the 0.01, 0.05 degrees of significance, which we'll be getting into for like the rest of the course. So those lines in the sand basically say the chances of me being wrong are really slim. So I'm going to go with the alternative hypothesis, and I'm setting that standard at 5% chance I'm wrong or 1% chance I'm wrong. Now, of course, there's some statistical complexity in there in terms of degrees of freedom and type 1 and type 2 errors that we have when we're looking at different types of tests. But the bottom line is if we're going to make a decision to reject the null and say there is something going on, we want to be really sure that our statistics support the notion that there's only a 5 or even higher 1% chance that we're wrong. So that's what we're going to be looking at in this chapter, looking at the construction of null and alternative hypotheses and how we get the pair. Always, when we're looking at a study and we're looking at the relationship between variables, there's always a pair, a null hypothesis, nothing going on here, and an alternative hypothesis, something is going on, and this is what we think it's going to be. And then we're going to relate that to where statistics comes in and draws the line in the sand and basically tells us when and under what conditions we're going to make those conclusions. So reading about that, I hope this little part here that I've done supplements what I put into the course book. You can read about that. Certainly send me any questions about this. We head into this week with a discussion, and the discussion relates to non-significant results. Now, the story behind this is in the field, and in the field of almost every level of science, publications have a tendency to focus on studies that have revealed alternative hypotheses. However, there is value in studies that say there's nothing going on here. That's it, and it's a missing part of the literature, meaning those studies don't see the light of day because they don't get published, because they don't have quote-unquote significant results. They don't pass that 0.05 or 0.01, but they do reveal information. They reveal when there's not a relationship between two variables. And that, in many cases, is often as important as when we do know that there's a relationship between variables. So the discussion focuses on that. And then the quiz actually goes into the notion of whether or not you're going to be conducting a one-tailed test or a two-tailed test. And that refers, the tails refers to the standard curve and the tails on the end. And what that means, let's say I'm going to have a medication that I'm going to test, and I want to see if the medication is both effective, but it also might be harmful. So it can have an effect in either way. That would be a two-tailed test. So all medication trials are actually conducted in a two-tailed test statistical manner, because we not only want to know when it's really good, when it passes that criteria for being really good, we also want to know if it's really bad. And it makes for more challenging statistics, meaning you have to take into consideration the fact that things might go bad, so your lines in the sand are actually more rigid. And you'll see a little bit about that in this chapter, but we're going to get into a little bit more where we actually have to take that criteria of 0.05 and divide it between both sides of the curve. So each gets 0.025 on each side. So you can see where it has to be even more short. If you're going to get a positive result on medications to offset any negative results, it has to not only meet the 0.05, but the 0.025. That's even further to the right on the curve, and even more assured that this is not by chance. And if we put the 0.01, it's going to be the 0.005. It raises the bar when you go two-tailed. So hopefully that will help. Read about it, look up the videos, try and get your noggin wrapped around the idea of these two hypotheses, the fact that significance means that it's very unlikely our results came by chance, the value of null hypothesis, and the whole concept of one-tailed test versus two-tailed test, depending on what we're trying to answer. And in particular medications, for example, we do want to know if it has a negative effect. The effect of a new teaching method, we might be only interested in whether it has a positive effect or not. Might not be interested too much if it has a negative effect. Depends, again, on some of the preponderance of the evidence from your literature review. So that's what we're going to be talking about this week. I hope this little lecture part has helped to clarify some of these things. This is a good one to get under your belt, because it's going to be significant, no pun intended, it's going to be significant for the rest of the class. So I will see you in the discussion boards, and please send me any questions you might have about details. Post them in the discussion boards, and I'm keeping an eye on those, and have a great week.